back to my logic garage. Today, let's talk about Carroll diagrams. Carroll, C-A-R-R-O-L-L, diagrams. Well, can't miss that letter, right? Diagrams. These diagrams are named after the English logician, mathematician, and novelist Lewis Carroll. What is Alice in Wonderland, Through the Looking Glass. Very famous writer, but also a famous logician, I think from Cambridge University. Now, before I talk about Carroll diagrams, I want to just refer to a previous kind of diagram, Venn diagrams. You've probably heard of those. I don't know if you're into math, you're into set theory, you probably also heard of Euler diagrams. Okay? Often in logic, you learn Venn diagrams, sometimes Euler diagrams, not so much Carroll diagrams, but I'm going to try to motivate Carroll diagrams right here and try to show why we're going to learn Carroll diagrams. Venn diagrams and Euler diagrams use circles to represent sets, to represent categories. So Venn diagrams often begin this way. If you're talking about two sets, sets are represented by circles. And what John Venn did, was to overlap the circles and talk about the relationships among sets that way. What Euler did was to embed circles within circles. They still represent sets, but you could say that every member of this set belongs to this set by diagramming circles in this way. So set theory, category logic, you can use Venn diagrams and Euler diagrams. And to do that, Carroll diagrams, you can do the same thing. That's the purpose of Carroll diagrams, to do category logic, to do set theory. But instead of using circles, what Lewis Carroll did was to use squares, or you could call them rectangles, squares to represent sets, or categories, terms, predicates. These are all different words to use, basically to say the same thing. Okay, or groups, classes, that kind of thing. He used squares, and he did not overlap the squares. We'll get to that. But first of all, I want to show you why we're going to use Carroll diagrams. One main reason why we're going to use Carroll diagrams rather than Venn diagrams. Venn diagrams work really well when you're talking about two sets. So if you have two sets, you'd represent it this way, okay, with two circles. So if you wanted to say that some, let's say, humans are vegetarians, then you'd write something like this. You'd write, this circle represents humans, call it H. This circle here represents vegetarians. And if you want to say at least one human is a vegetarian, some humans are vegetarians, you put an X right there. So that's the way Venn would diagram this statement right here. Remember what standard form this is? This is an I statement. That's an I statement. Okay? Venn diagrams also work quite well when you're talking about three sets. So you could diagram it this way. You could talk about humans, vegetarians, and then, let's say, P could be primates. P could be primates. Okay? And then you could talk about all the differing kinds of relationships between these sets. And this way of diagramming the circles works well. Okay? You could have a human right here who's right here, who's not a vegetarian and not a primate. Let's call that primates. Right here you would have a vegetarian who is not a human and is also not a primate. Right here, any member of this little set right here, this, call it a region, would be a vegetarian who is a primate but not a human. See how that nicely represents that region? Okay? Also, the way Venn diagrams are set up, you can also imagine a member outside this set. So you can imagine someone or something that's neither human, primate, nor vegetarian. It could exist out here. If something existed in the middle, it would have all three predicates, right? It would belong to both set of human, set of vegetarians, set of primates. It would exist right there. Okay? Venn diagrams work quite well that way. By the way, notice here that there are 8 regions, right? 1, 2, 3, 4, 5, 6, 7, 8. 8 regions. Different combinations of sets. That corresponds, think about this, go to the truth table. If you have 3 statement letters, you would have 8 rows. Similarly in Venn diagrams, if you have 3 sets, you'll have 8 regions. 3 valves on a trumpet, remember that? 3 valves, right? You would have 8 possible combinations of valves. All right. Now, primates shouldn't either. Venn diagrams have a limitation though. When you talk about 4 sets, by the way, 4 sets should have 16 regions. We learned that. Just like in a truth table, if you had 4 statement letters, you'd have 16 rows. Well, I kind of dare you, I challenge you to put 4 circles down and get 16 regions. So if you do something like this, again, 1, 2, 3, 4. Wait, there's a little region right there. You see that? Okay, that looks pretty good. That looks pretty good, right? So let's try this out. You have 1 region out here. 1, 2, 3, 4. That one's 5 right there. So we'll call that 5. 6. Should have made this bigger. 7, 8, 9, 10, 11, 12, 13, 14. What? Wait, there's 2 missing. We want 16. We only got 14 regions, even when we include the region outside all the circles. Ouch. It turns out that the way to use, you can look it up online, check it out. Do 4 sets using in Venn diagrams. You find some really cool shapes and stuff. Let's see. I think people do it one way of doing it is like this, and then they go like that or something like that. There's always funky ways. I don't think that it looks like goggles on 3. I don't know. I'm not going to count this up right now. That's probably like 50. I don't know if that's going to get 16. You could try it on your own, but it's a pain. It is a pain. Carroll Diagrams is much easier to do 4 sets. So that's a reason to use Carroll Diagrams. Another reason, it's maybe not the main reason, is that in a Venn diagram, you have this outside region. In a Carroll diagram, we don't refer to an outside region. We don't need it. So that's kind of cool. I'm not saying Venn diagrams are bad, you shouldn't use them or something, but there are some limitations, again, when you're dealing with 4 or more sets. Whereas Carroll diagrams, you can kind of easily handle that. All right? Let me erase this board and I'll get back to you. Let's learn Carroll diagrams now. Say we're talking about two categories. dogs, and canines. What Carroll diagrams do is this. All right, if we have two sets that we're going to talk about, two categories we're going to talk about, we're going to need 4 squares, right? Just like in a truth table, if you had 2 statement letters, you have 4 rows. Okay, so you begin this way. A large square right here. You're going to make 4 squares in this way. Okay, now let's call the set of dogs, or the category of dogs, let's call that D. And let's call the set of canines, let's call that C, capital C. All right, let's represent all the dogs this way, horizontally. And we'll explain why they're going to be represented by 2 squares here, 2 regions. Dogs will be represented by regions 1 and 2. Okay, dogs, regions 1 and 2. Okay, so let's say sets right here, and then this would be the regions represented by dogs. Now, let's take canines. Put canines here, and again, I'll explain this. Canines will be represented vertically by these 2 regions or squares. Canines, 1 and 3. 1 and 3. Okay? There is a 4th region here. Let's call that 4. All right. Now let's talk about the other regions and the other possible combinations, I guess you could say. So dogs are represented by 1 and 2. Canines are represented by regions 1 and 3. Okay? Non-dogs that is, anything that is not a dog is going to be represented this way. Capital D with a line over it. This line over it means the complement of dogs. Complement with an E. Anything that is not a dog would be in its complement. Like I don't think I'm a dog, so I'm part of the complement set, the complement category of dogs. Non-D. Non-D. Let's represent non-dogs with regions 3 and 4. Now, what about non-canines? Well, that's a set as well. That's a set of all things that are not canine. Non-canines. Not C. Let's call it right there. That's represented by regions 2 and 4. Okay? So, think about this. Let's call this Mark, right? I'm going to represent myself as an individual with a lower case letter. Little m right there. So where does little m live, so to speak? I don't think I'm a dog. I don't think I'm a canine either, right? Okay? So I reside, so to speak, in region 4. Okay? Because I'm not a dog, so I'm not in 1 and 2. I'm not a canine, I'm not in 1 and 3. The only remaining region would be 4. So I'm there in region 4. I live in region 4. Okay? And presumably, all viewers of this video, I don't know. Maybe dogs are watching this video, I don't know. But probably many of you are human. So I would say most of the viewership, the 9 of you, right, who are watching this video, would all be here, would be populating this region, number 4. Okay? So each of these squares represents a region, represents a certain membership. Okay? Now, if there's something in a region, okay, or if you want to say that there's something, if there is something in a region, okay, put an X there. Now, if you know the name of the individual, like me, little m, then you could put an M in there instead. But if you just want to say there's something, there's at least one thing in that region, put an X there. So, because I'm human, I'm neither a dog nor a canine, right? That means there's at least one thing in the world, in the universe, that belongs to region 4. So I can put X right there. See? That's how a Carroll diagram works here. If there's nothing in a region, if there's nothing in a region, put a 0 there. 0, standing for nothingness, really, in that sense. So let's see. Where would it make sense to put a 0? Look at this. Will you ever find a dog that's not a canine? You won't. Every dog you ever meet, you ever will meet, is also a canine. Every dog would belong to region 1. No dog would ever belong, right, to region 2. So let's put a 0 in region 2. Does that make sense? So just hold it there for a second. This is important to be able to see this. And X means there's at least one member of this region represented by this space, the square. See, it's a nice visual. 0 means there's nothing in this region. 0, empty space. By the way, in Venn diagrams, the standard thing to do would be to blacken this out, just shade that whole region. But for Carroll, he puts a 0 there. Now let's learn how to Carroll diagram our standard form categorical statements. Let's Carroll, I guess I should capitalize it. Let's Carroll diagram our 4 standard form categorical statements. A, E, I, and O. Okay. We've already done the A statements. Check this out. I'm gonna rewrite this. I'm gonna rewrite this right here. So let's again talk about dogs and canines. I'm setting the diagram up here. Regions 1, 2, 3, and 4. If I want to say all dogs are canines, so I want to say all dogs are canines, then remember what that is. Every time you have a dog, it will be a canine. In other words, you're never going to find a dog that is not canine. So you put a 0 right there. Okay? All dogs are canines. So This is how to diagram, using Carroll diagrams, the statement all dogs are canines. For a universal statement like this, an all, you're going to use a 0. You're not going to use an X. And here's the quick explanation of that. Well, the way our system is set up is that this is our default, at least. If you make an A statement, all dogs are canines, you don't assume that the subject term actually, or at least there are members that belong to the subject in existence. You don't assume that is the case. Because what if I said something like, all elves are clever. That's stereotypical. I don't know if that's even true or something. All elves are clever. If I say this, I guess I'm talking about these mythical, magical creatures. I don't really believe that elves exist, but I'm saying, I guess if there were elves, they would be clever. Or in the world of fiction, elves are clever, something like that. I'm not saying that elves actually exist. Now, if I were saying that elves existed, or that dogs exist, all dogs are canines, plus dogs exist, then I would need to put an X right there. In other words, I'd be saying some dogs exist, and they are not, okay. Oh, they would have to be canines, right? You're never going to find a dog that's not a canine. And there are dogs. By putting an X there, I'm saying there exists at least one dog. See this? So actually right here, I'm saying, by putting an X here, I'm actually saying some dogs are canines. So that's an I statement. I've actually just diagrammed an I statement. Here, I've diagrammed an A statement. Okay? Let's diagram an E statement. Let's diagram an E statement. Next. Okay, let's say that no dogs are amphibians. Amphibians, let's spell this correctly. Amphibians. No dogs are amphibians. Okay, I haven't told you about the kind of the order we do this in, but the subject term, or the initial term you see, put on the upper left here. We're talking about dogs here. And then again, that will be represented by regions 1 and 2 horizontally across. The next term right here, in this case it's the predicate term here, let's put on the upper, right, on the top left-hand column here, going vertically down, amphibians. And that's represented by regions 1 and 3. Okay? And then regions 3 and 4, let's call them those non-dogs. And then regions 2 and 4, let's call those non-amphibians. Okay, so just try on your own right here, using either an X or an O, think about that. How would you represent the claim, no dogs are amphibians? I think I mentioned before that if it's a universal claim, you need to use a 0, because that means nothing. See how universal it is? That's talking about every member of a set. Whereas if you use X, that means at least one. That's not talking about every member of a set. So that would not be a natural thing, natural symbol to use to represent a universal claim. This is a universal claim. There is no member of the set of dogs that is an amphibian. So you're going to be using a 0. Right? You have 50-50 shot there, right? 0 or X. Use a 0. Use a 0 for universal claims. Now the next question is, where do you put the 0? Okay? Here it is. Here's just a simple rule. Keep in mind, you always got to use this. Put your symbols, okay, whatever they are, zeros or X's, only where the subject term is. Why? Because you're talking about the subject in these statements. What is the subject? Dogs. So whatever symbol you use in a Carroll diagram, you need to put it only where the dogs live, so to speak. Where do dogs reside here? Where do they live here? Regions 1 and 2. Okay? So that means that you're going to be using a 0 since it's a universal claim. Where are you going to put the 0? It's not going to go in 3 or 4. Why? Because that's where non-dogs are. You're just talking about dogs though. So you already rule out half the regions right away. So you know the 0 is going to have to go in 1 or 2. Where does it go? So, right, the 0 will have to go, the 0 will go in 1 or 2, not 3 or 4. Okay, 0 again means there's nothing there. Okay? One thing to keep in mind is we put let's see, when we said all dogs are canines, we put the 0 in 2. So that's maybe a hint. If you want to say no dogs are canines or amphibians, whatever that is, the 0 should probably not go in region 2. So let's try this out. Put a 0 right there. Okay? This tells us that there's nothing in the region of dogs that are amphibians. So there's no DA. Okay, you understand what that means? Right, something that's a dog and amphibious, that does not exist. Isn't that the same thing as saying no dogs are amphibians? You're never going to find a dog that's an amphibian. So there's nothing that exists in region 1. Empty. This is, we've just diagrammed the E statement. Okay? Another way to look at it is this. Dogs are represented by regions 1 and 2. Amphibians are represented by regions 1 and 3. You look at where those regions overlap. The shared regions, in other words, that's region 1. So there's going to be nothing in region 1. Now notice this diagram says that there's nothing in region 1, but it says nothing about regions 2, 3, and 4. It makes no commitment about any of those. If you don't put a symbol down, your diagram says nothing. Like if I take this out and I just have this, we're set up to talk about dogs and amphibians. But until we put a symbol down, this diagram literally means nothing. This diagram represents nothing. No thing. Okay, nothing. Right? Doesn't say anything. If you want to say something, then you do something like, little m, Mark, right, is non-dog, non-amphibian. Or if you want to say, hey, some dogs, let's say, what if you said something like this? Some dogs are amphibians, right? Like, my dog, I don't know, Unlucky, that's a bad name for a dog, I guess. But Unlucky, Unlucky can actually swim. Loves to swim. I think Unlucky's actually amphibious. I mean, there's even like webs between, right, and its paw between its claws or something. So you'd say, at least one dog is amphibious. Some dogs are amphibious, in other words. If you wanted to say some dogs are not amphibious, again, you're talking about dogs, so you can do like this. If you wanted to say So this would represent some dogs are not amphibious. Maybe we should write that down. Some dogs are not amphibious. So this is an O statement right there. If you wanted to say some amphibious things, right, are not dogs, then you'd put an X right there. Okay? All right. So we've actually diagrammed all A, E, I, and O statements. I and O statements will be diagrammed using this. We're using an X. A and E statements will be diagrammed using a 0, because these are universal statements. These right here are particular statements. To summarize what we just learned, this is how Carroll diagrams represent each of these standard form statements. A statement is represented this way. The 0 is in region 2 here. Okay? All dogs are canines. They're not going to be non-canines. No dog is a canine. That's what this says. It's false, but that's what this says. Region 1 is empty. I statements, some D's or A's. Put an X, that means at least one. There's at least one member in region 1. At least some dog, at least one dog is an A. Or D is an A. If you want to say some D's are not A's, right? You'd say there's at least one member of the region of dogs, right? And non-A's. So that's region 2. So I'll leave this here. Make sure you're very comfortable with Carroll diagramming each of these standard forms. The next thing that we'll do is to start diagramming, I guess you would say, non-standard categorical statements. And we're going to be testing for logical equivalence. So see you next time.